The next experiment is the fourth one is control of pressure process. Control of a pressure process using P and PI controllers. If you use P controller, then definitely there will be a steady state error that you can notice here. If you use PI controller, no steady state error that you can notice. But pressure process, level process are having almost identical time constant. That's why this pressure process can be tuned by using reaction curve method, RC method. But it's not possible to do sustained oscillation method as we did for flow process. RC method can be used to find the tuning parameters. RC method can be used to find the tuning method, but already we studied RC method in level process. That's why you will be provided with tuning parameters for P and PI controllers. Tuning parameters will be given. That's why you have to do the bumpless transfer and you have to control. What is the structure of that process? The loop consists of a pressure cylinder, pressure tank will be there, pressurized vessel will be there. The input is from another pressurized vessel that will be regulated by a controller. This is from a pressure source and it is given to this tank, pressure tank. This pressure is applied to another process or somewhere it is used. That's all. Here it is open to atmosphere. We are not going to use that pressure. That's why it is open to atmosphere. Our aim is we have to maintain the pressure inside the tank some constant. That's why we need a pressure transmitter is required. That gives 4 to 20 milliamps. That gives 4 to 20 milliamps as the range varies from 0 to 100%. Pressure changes, it gives 4 to 20 milliamps. That is given to a controller. Either it may be a P controller or PI controller. Set point will be given. Set point will be given. The controller output is again 4 to 20 milliamps. That has to be given to I to P converter. Its output is 3 to 15 psi. It's given to the valve. This is the closed loop arrangement. Here, this pressure transmitter is a two-wire transmitter. Two-wire transmitter. That's why this transmitter and power supply 24-volt power supply and load all are connected in series. This output voltage drop across this resistance 250 ohm. That load is given to the PID controller. This PID controller. This is the PID controller. This is given to the PID controller. This is the connection diagram. So how to do the bumpless transfer? Initially, let us do the servo response using P controller. Servo response using P controller, P only controller. Servo response using P only controller means the first step is bring the process, put PID controller in manual mode. Manual mode. Second step is adjust the output. Adjust output of P only controller. So put the controller in P only and enter the tuning parameters. Here, put the PID in manual mode. P only with correct tuning parameters. Correct tuning parameters. Then adjust output of the P only controller to bring the process to nominal operating point. Say 50%. Say 50%. Adjust the controller output to bring the process to nominal operating point. The third step is once it is ensure that the process is settled. Ensure that process, the pressure is settled at 50%. Settled at 50%. Then make set point equal to PV. Make set point equal to PV. Then transfer from manual mode to auto mode. These three steps are called bumpless transfer. Bumpless transfer. Now the process is at closed loop. That time give change in set point. Set point change. Give set point change. Then you will get the response like this. This is the set point. Say 60%. Initially, the process is at 50%. So you will get the response like this. You will get a steady state error. You will get a steady state error. You will get a steady state error. Then once it is settled, suppose it is settled at 57%, say, there you can give disturbance to get regulatory response, or again you can bring to the 50%, or you can bring again to 50% and give disturbance. How to give disturbance? You can give anywhere. Here, we can open this valve more or we can close slightly, so that you can open or you can close this valve so that the output resistance is changed. That's why the pressure inside will change. Let us assume that we closed. That's why there is an increase in pressure, but controller takes necessary action. That's why it will settle somewhere like this. So again, steady state error will be there. Steady state error will be there. This is the regulatory response. Regulatory response. Now, let us do the same, but with the P plus I controller. The same steps, put the PID controller in PI mode, enter the correct tuning parameters, adjust the output of PI controller in manual mode, put the PID controller in manual mode, put the controller in PI control mode, enter the correct tuning parameters, then adjust the output of the controller to get the nominal operating point, say 50%. That is second step. After that, ensure that the process is settled at 50%. Then make set point equal to PV, transfer from manual mode to auto. Ensure that the process settled at 50%. Make set point equal to PV. Make set point equal to PV. Transfer from manual mode to auto mode. These three steps are called bumpless transfer. Then give the process at 50%. Save. Now give set point change. You will get a response. But because of PI controller, there won't be any steady state error. It will settle at the set point. Once it is settled, now you can do the regulatory response. No need to do any changes here. But in here, But initial value, you have to assume that P7. If you give regulated response done here. Now you can adjust this output valve so that the output resistance is changed. That's why the process will deviate. If you close, if you open more, it will decrease. The pressure will decrease. Anyhow, the controller will take necessary action and bring back the process to set point. That is called regulated response.